In 1969, a lovely English guy called Colin started a new company, and this company was providing electrical switching circuits for pipe organs. He also started a recording studio called Acorn in an Oxfordshire village. In 1976, when he decided to have a new console for that studio, his company, he felt, had everything that he needed to actually build his own console. So his first iteration of a desk was called the Series A, obviously. When he got to his fifth iteration, he did something that would be considered remarkable, even by today's standards. He put a discrete compressor and gate circuit in every single input channel, and slap bang in the middle of this console, he put the world's first integrated desk stereo bus compressor right there in front of every engineer and producer that used the damn thing. The desk was, of course, the SL4000E series. Colin Sanders' company was called Solid State Logic, or SSL. Now, let's just create a hypothetical situation. It's late at night, you're recording a band, everybody's tired, they kind of want to go home. People have heard the song on repeat all day long. It's your job as a producer and an engineer just to kind of G them up a little bit and give them something to listen to back in the car. So what do? You throw together a rough monitor mix. Now that can always sound quite shady depending on the level of the recording that you've reached at that point. But then on an SSL, E-series and beyond, you could just reach for that magic button, the button that says in, and suddenly one of the most punchy and present compressor circuits that has ever been created would fly all over your mix, and everything would sound a little bit better. It would start to glue everything together. And because of that, this has become one of the most loved and most important compressor circuits of all time. It is what's known as a VCA compressor, and VCA stands for Voltage Controlled Amplifier. A VCA compressor will take a DC control level signal and use that to either attenuate or increase the level of the actual volume of the signal that is going through the device. It's very, very simple. If you can imagine your hand on a volume knob, think of that as the control signal. You're either going to turn it up or you're going to turn it down. And that can be a static voltage. VCA compressors are known to be really punchy, particularly when you set the attack speed at quite low values. So in other words, every time the compressor kicks in, there's a little bit of the loud audio that manages to kind of sneak past the actual circuit. And that is certainly the case for the SSL bus compressor. Now, there's been many, many different iterations, but my favorite is always the classic going back to that E-series console. And they actually used a series of VCA chips by a company called THAT. That's right, T-H-A-T. And the THAT chips have been used in compressor circuits ever since, right up to the modern day devices. This is SSL's Bus Plus, a brand new take on this kind of compressor system, and it actually has the THAT VCAs inside of it. One of the brilliant features of the SSL bus compressor was being able to set its release timings or its release speed to an automatic value. Now, as a sweeping generalization, the attack of a compressor, particularly when it's applied over an entire mix, will control the amount of punch that you hear, because basically what's happening is as the volume level drops, the attack control, as you set that to a slower speed, allows little bits of the loud audio just to jump through, as we've said before. The release timing of a compressor can actually be set to almost work to the groove and the tempo of your track, and this is really important to understand. However, a lot of records kind of change as they progress, and sometimes maybe all of the drums come out and a section's a little bit washier, particularly as dance music really took hold. And the SSL bus compressor allowed for an automatic release timing. This is a very clever little bit of circuitry that will basically look at the incoming audio and decide from that how fast or how slow the release should be. And this is excellent when you come to breakdowns and dance records and things like that, because whilst the drums are going in, the detection circuit will probably go, okay, we need quite a fast release time there so that it's coming back in time for the next kick drum, etc. But then once you get to a nice breakdown and there's lush chords, bang, we can go to a slower time. And you will see this an awful lot in modern compressor design too, because obviously this is something that's really easy to do in digital control systems. And as you can see, the control systems that are absolutely vital to the best operation of these devices are getting more and more complex as we start to travel through time. Now, just to give you an idea of the importance of this compressor technology, in 1996, Billboard magazine estimated that 83% of its number ones were mixed on SSL desks. That's an extraordinary number, and I guarantee you nearly every single one had the bus compressor engaged. Now, we haven't really even mentioned the little compressor that's in each channel, but it's immensely punchy, and there's a great little trick, particularly for drums, that you can try on any decent SSL emulation of a channel strip, that is. Turn the ratio all the way to the top and turn the release down to absolutely nothing and leave it on slow attack. So make sure that that fast attack button's not in, and then just dial in a little bit of the compression threshold. And you'll actually hear the sound of particularly drums actually start to rise, as it does something really unique within that circuit. And there's one little oddity that I found out about the E-Series bus compressor. You've probably heard the term balanced and unbalanced, and you may know about those kind of different types of ways of transmitting audio. But normally professional audio gear is balanced pretty much all the way through. But the SSL E-Series bus compressor actually worked completely in an unbalanced circuit. And actually SSL have replicated that with this 4K button on the Bus Plus compressor that they've just recently released. And you can even dial in a progressive amount of deliberate VCA distortion. So once again, we're in this wonderfully cyclic manner of technology where we kind of want the best of the old stuff but dragged forward into a modern format. Now, loads of other desk manufacturers then followed suit, and Neve consoles around at the same time had compressors and gates on every channel too, and even compressors built in. There was a brilliant Focusrite desk that was in the Metropolis studios in London, in Studio One, for many, many years. That used the famous now ISA channel strips and gates and compressor again on every single channel. So this, as you can imagine, changed everything about the way that music was mixed and recorded, and suddenly everything started to have this real edge that was created by multiple layers of dynamics. Suddenly you could not only EQ every single noise coming in from a tape machine, but you could also make it slightly punchier. But we can't stop the story about SSL without talking about one other little-known compressor circuit. Inside a big format console, when you've got it connected up in a recording studio, you're going to have a lot of musicians potentially in the live room, and in particular the drummers have a problem of communication in that they may not be that close to a microphone, and you'll often see them lean down to talk into the snare drum microphones or lean off to one side to talk into the hi-hat mics. So the guys at SSL, being rather smart, created a listen mic circuit within the desk. So basically you could dangle a mic down from the ceiling, have it in the center of the room, and it would pick up pretty much anybody talking in the room. And the reason it could do that is that it had an absolutely beltingly powerful compressor connected to it called the LMC. Nearly all of us know the name Phil Collins and the cacophonous drums, amazing drum part that comes in halfway through In the Air Tonight. But this drum sound actually appeared first of all whilst Phil was drumming on Peter Gabriel's latest album. Now, they were in the Townhouse Studios in London. It had a great big live room, and they had a listen mic set up so they could talk backwards and forwards. And apparently, not quite sure exactly how it happened, but Phil was playing and someone pressed down the listen mic compressor, and the drum sound that was being picked up by this single microphone was smashed to pieces by the listen mic compressor, and they heard both at the same time. And apparently it was revelatory, and that was going to be the sound that they wanted for the drums. Now that's not easy because the listen mic compressor inside an SSL was not ever patched in a way that they could get to. But overnight the techs at Townhouse Studios did. They found a way to give them access to that compressor, and that drum sound that defined the 1980s was born from that moment with yet another compressor circuit design from SSL. It's extraordinary when you actually think about it. SSL weren't the only game in town for VCA compressors, and one of my favourites is obviously DBX, and their 160 range of compressors are pretty much still everywhere in recording. The really early old units used pretty much, I believe, the same VCA chips that were used inside the SSL bus compressors. But the sneaky little sausages at DBX did something really clever. Inside of their detection circuit, they created what's known as a soft knee. Now you will see this a lot, even on plug-in designs, and you may wonder what on earth one of these has actually got to do with compression. It all comes down to how a compressor's action looks like when it's being plotted on a graph. If we have a signal coming in and passing through with no compression at all, it's pretty much a straight line like this. Now, when we actually draw the threshold line down, and let's say it's here, and then we start to apply compression, the actual output signal will start to be attenuated above that line, and then this is where you get this break point. And as you can see, the line then changes angle. And that's simply because the output's being attenuated. But as you can see, that break point there is nice and tight. It's a perfect two lines just intersecting. Now, a soft knee type compressor is when you take that point and you turn it into a gentle curve like this. So effectively what's starting to happen is the compressor is kicking in a slightly lower capacity before you get up to that threshold point, and then the transition over into full compression is a little bit more subtle and softer, and this gives a much more pleasing and gentler tone to the compression that is really lovely, particularly on bass instruments. And that's why the DBX 160 is absolutely legendary for bass guitar, and I can highly recommend it for bass synths, anything basically that can do with a kind of much softer approach to compression. Now, whilst we're talking about the terminology involved in compressors, let's talk about the threshold. Why do some compressors have an actual threshold control and others don't? A perfect example is the 1176. You've just got input and output. Well, actually it does have a threshold, but it's fixed. So what you're doing when you use an 1176 is using the input control to drive the audio level up to that fixed threshold point where it starts to act. Now, sometimes the actual physical knobs that control the threshold may be named differently. For example, on the LA2A, it's actually called gain reduction. And basically, as you turn this up, you are effectively changing the threshold position and the compressor starts to act. So now let's talk about one of the most important aspects of compression, and that is the compression ratio. Now, you may see it marked on either plugins or physical devices with numbers like 2:1, 4:1, 8:1, infinity to 1. Now, I always find that if you start mentioning things like ratios to musicians, they run a mile, because we all know this kind of stuff from maths. And it can be a really difficult concept to actually grasp. But let me give you a great analogy. Have you ever put a bet on the GGs? Well, what were your odds? Were they 4:1, 7:1, 44:1? I got a 44:1 winner once. Very, very pleased, as you can imagine. It's the same thing. Odds are basically a ratio. So let me give you a practical example. We know we've got a fixed threshold that either we control or is set inside the compressor, and here comes our volume level. It's rising up, nothing's going to happen until we reach that threshold. Then the only bit that's going to be affected is the volume that happens over the top of that threshold, okay? So say now our volume reaches 4 dB above that line in the sand that we call the threshold, and we've got a 4:1 ratio. The compressor will only let 1 dB of that signal through, 1/4 of the actual jump. So let's say, let's take a 4:1 as another example and say our signal exceeds it by 8. So we divide that 8 by 4, the compressor will only allow 2 dB through. Now, let's say that you've set your ratio now to 8:1, and then that 8 dB signal comes up. Again, it's only going to let 1 dB through. And if you now went 16 dB above that threshold point, it's only going to let 2 dB through. So as you can see, this is kind of exponential. And the tougher the ratio is, the higher the ratio, the number, then the stronger the effect of the compression will be. And you will really hear that in the audio. This is one thing that I really encourage you all to just stop making music for a bit and actually go and investigate. Now, when you reach infinity to 1, a slightly different thing happens. No audio is going to be allowed past the volume level of that threshold. So in other words, here comes the volume level of the music. It hits that threshold level, and basically your name's not down, you're not coming through. That is what limiting is all about. Now, these kind of things are so useful in broadcast industries because you don't want any signals to exceed a certain limit when you're sending huge voltages out to aerial arrays to actually transmit the signals. And yet again, it's a perfect example of how the broadcast and the music industry have sat side by side and sometimes interplayed. There is an amazing little device called an Optimod made by a company called Orban that specialised in an awful lot of transmission systems. And it's one of the first multi-band compressors I've ever seen. It was around in the 80s and used heavily on FM stations. And if you remember that nostalgic feeling of that power that the music had on a stereo FM broadcast, particularly in America, 9 times out of 10 it was probably down to one of these devices. I'd love to pull one in here and see what it sounds one day. So if you know anybody in the UK that's got one and wants to lend it to me, please let me know. So far we've covered valve, opto, FET and VCA compressors, but they're not the only games in town. So let's now discuss the others. And one of the most widely known is called diode bridge. Now this is a picture of a diode bridge circuit diagram. And as you can see, it's a nice pretty little diamond with 4 diodes spread about. This is very, 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 very handy because it can rectify an AC current. In other words, it can take the negative portion of an AC current, flip it up and turn it into a DC portion and effectively change AC to DC, which is why you find an awful lot of diode bridges inside of power supplies. But diodes normally allow current to go just one way. But at the very lowest operating levels, a little bit of it can sneak through and it can actually transfer current in 2 directions. And that characteristic is what is used very carefully in diode bridge compression. Now, I'm not going to go into the electronics or the maths because it's complicated. And basically what's happening here is you have a voltage controlled attenuator. And that's exactly what you want for a compressor. Now there is a problem though, because in this kind of design, you're actually operating the diodes at the very lowest levels of their spectrum. Now this means that the electronic design for this kind of compressor is going to be very complex to actually manage because you've normally got a whacking great big AC power supply inside one of these boxes. But that of course was absolutely no real trouble for one of the brilliant and legendary designers in the audio engineering community, Rupert Neve. And all of his main compressor designs pretty much are diode bridge designs. And here I mean the 33609, the 2254, and even some of the more recent 500 series modules. Now on the plus side, diode bridge compressors can act incredibly quickly, and that gives them a real power when it comes to working on things like drums or stereo mixes and all of that kind of stuff. And also they are non-linear compressors, and that means there's a degree, once again, of harmonic distortion. And we love all of this stuff. So they have quite a distinctive sound. They wouldn't still be selling these designs if they didn't work like that, but they are difficult to make and they are expensive. Now there's one type of compressor that I've only found out whilst researching these videos, and that is called PWM compression, or pulse wave modulation. And yes, it is that kind of pulse wave that you may be familiar to in synthesizer design. Now we can think of a single cycle of a square wave as having 2 states, almost like a digital system, an on state and an off state. A square wave has the dividing point exactly 50%, in other words, right in the middle of that actual waveform cycle. What we can do is actually move that position, in other words, have either less or more of the on state, and that kind of control is called pulse wave modulation. So how does this work inside a compressor? Well, what you can do is have an audio signal coming in and amplitude modulate it with those kind of pulse waves. So in other words, when that cycle is in its up stage, the audio is going through, and when it's off, you don't hear it. This creates a constantly rhythmical on-off modulation of the audio. Now, obviously, if the speed of the PWM wave is slow, we could actually hear that as almost like a gating effect, a chopping effect. If you take that PWM wave and speed it right up, and I mean way past the 20 kilohertz of the limit of human hearing, probably up more like the 100 kilohertz range, you don't actually hear the individual chops of the audio, But as you move that pulse width to a smaller amount, so in other words, there's less on signal, you effectively hear the level of the audio drop. This is the world's fastest trance gate. But because you do not hear those changes because they're so far out of our human range, all you get is the attenuation. And here's the key to this. The reason why this can be so useful is that it can happen instantly. So fast. If you think about the control rates that we're talking about here, and the faster the better with PWM compressors, then it can turn literally in a microsecond and change the volume. So all you've got to do then is develop a really good control circuit, one of the most accurate pulse waves that you could ever create at such an incredibly high frequency, and then create a detection circuit that's able to move the pulse backwards and forwards depending on whether the volume needs to go down or not. That is no simple task at these kind of frequencies, and I believe it's one of the reasons why we don't really see this in digital compression, because we would have to oversample so dramatically to actually really get this working. A perfect example of this is Dave Hill's Cranesong STC-8. It's an amazing compressor and limiter, but it is incredibly uncoloured because of this system. And the reason it costs so much is because of the electronic design that is required to get this thing operating correctly. But believe it or not, there is an example right down on the budget end. ART make a dual channel limiter and compressor that uses PWM techniques too. So listen, I had no idea about this until I started this video. I'm now fascinated. I'm going to go and look at Wave's Pi compressor because, believe it or not, that is a recreation of a PWM historic compressor. So I'm really going to go and check this out. I encourage all of you, if you've got it, to just have a look at that too. Now, whilst the analog world in the mid-80s was doing incredibly well and dramatically expanding the way music was made, produced, and all the rest of it, a couple of Japanese companies were eyeing up digital audio. I've actually used a couple of major Sony 24 and 48 track digital tape machines. They're incredible pieces of technology. I believe I'm right in saying that the head on them actually had a Ruby built into it so that it could get the huge amount of information onto the tape and back off again properly. But of course, they weren't going to just stop at tape machines. They wanted to see if it was possible to build an entire ecosystem digitally. And slowly and quietly in the background, Sony put a team together and developed the Sony Oxford digital console to go with their tape machines. This eventually got taken up by an awful lot of very big producers, the likes of Peter Gabriel and Mike Oldfield at the time. I've seen Mike Oldfield's device. But they wanted the similar functionality that was inside of the old SSL consoles. So they started on their first types of digital compressors using nothing more than DSP code. This is the Sony or Sonnox Dynamics plugin, and I believe it's a one-for-one copy of the code that was actually running inside of the Sony Oxford console. Again, this was one of those pivotal moments in music production history, and you know what comes after this. This is one of the precursors to every single compressor plugin you use today. So join us next time as we head into the world of digital and beyond.